have like homework. Okay, we're like 12 minutes late. 6.3 division. Division. All right, here we go. So I'm going to make this short and sweet. Dividing fractions. Keep, change, flip. KCF.
I remember this.
Keep first fraction. Change division to multiplication.
Did we learn this last year?
Oh yeah. And then flip second fraction.
I learned this in 5th grade too.
And then multiply. I had all kinds of stuff about reciprocal and this and that. Let's just KCF. Keep, change, flip.
KFC.
I know, chicken.
That's what I thought every time.
Fried chicken.
Kentucky chicken fried. Kentucky fried
I actually I have multiple Thanksgivings because of lots of family. One of them we always have brisket.
I'm now having one this year, but I usually have 3.
Okay.
I usually have 3. But now
Example. Two over 5 divided by 4 over 9. We're going to keep, change, and then flip. So we're going to keep the first fraction, change the division to multiplication, and then flip the second fraction.
Would there ever be an instance where it's multiplication and then we change it to division?
No, never. Now, let me just warn you. If you decide to flip the first fraction instead of the second, it will be a wrong answer. It's always only the second. Now,
Oh, shoot, I flipped both.
no, you don't do that. You keep the first one, change to multiplication, and flip the second. Yes, ma'am.
Why would it be different? Because if you flip the first one, it would still...
Trust me. It will be different.
Okay.
Now, based on what y'all learned yesterday, is there a number that can go into 5 and 9 evenly for cancellation?
Mm-hmm.
What number besides 1?
45.
No, can go into.
Oh, no.
No. What about 2 and 4?
2.
That's right. So, 2 divided by 2 and 4 divided by 2. 2 divided by 2 is?
1.
Put a big old 1. 4 divided by 2 is?
2.
2. Now we multiply across. 1 times 9 is?
9.
And 5 times 2?
10.
There's your answer.
I remember this.
Good.
It was fun.
Cancellation.
All right, here's another example. Does everyone have that down?
Yes.
All right, good. 4 and 7/8 divided by a big old -3. Ooh. Okay, so when you're dividing mixed numbers and everything, what do you think you got to do first?
Flip, change to a multiplication.
No. Joseph?
Change it into an improper fraction.
That's right. We got to change this to an improper fraction. So 8 times 4 is what, Joseph?
32.
Plus 7.
39.
So 39 over 8. and I'm just going to write it out, divided by, what do I do with this negative whole number, Joseph?
Change it into -3 over.
Very good. We just stick it over a 1. Yes, ma'am.
Where'd you get the 1?
Okay, so anytime you have a whole number, to change it to a fraction, a whole number to a fraction, if it's all by itself, you just stick a 1 underneath
Oh,
it.
okay. Wouldn't that just equal -3?
Yeah. But since we're dividing by a fraction, we have to put this into fraction. Okay, so now we do the keep, change, flip thing.
KCF.
KCF. So the first fraction we keep, we change the division to a,
Multiplication.
and then we flip this fraction. It's still going to be negative, but it's now -1 over 3.
That's confusing.
Well, this whole fraction
Yeah.
is a negative.
Right.
So we're flipping the numbers, but it's staying a negative. Okay, can we do any cancellation on these?
Yes, we can.
Which ones, Joseph?
39 and 3.
What number goes into 39 and 3 evenly?
13.
Wait, what number goes into them evenly? 3, right? Now, 39 divided by 3 is, in fact, 13. 3 divided by 3 is 1. I can't do any cancellation here, so now I just multiply across. So a positive times a negative, the answer is going to be, so 13 times 1 is,
13.
and 8 times 1 is.
8.
Now let's put that in mixed number. Joseph, how many times does 8 go into 13?
1.
So big O 1. What left over?
5 over 8.
Very good. So it's -1 and 5/8. Yes.
Can we work out how we get the leftover thing? 'Cause I
Yeah.
forgot how to do that.
Okay, so if we have 13 over 8, we're dividing. How many times does 8 go into 13? So there's my whole number. 1 times 8 is 8. I have left over 5, and so my remainder is 5. So the answer is my whole number. The remainder is my numerator. And then my divisor is my denominator.
So you just keep the denominator.
Yep. There you go. Bless you.
Thank you. Okay.
So the answer is your whole number, the remainder is your numerator, and then the denominator stays the same. Any questions so far? Okay. Dividing decimals.
Excuse me.
Change the divisor, which is your horse.
Horse.
Yep,
Why you got a horse?
you'll see.
How about a cow?
No, okay. Okay, change the divisor to an integer, meaning having no decimals. So you got the divisor is a number right here outside the house. If it has decimals, you want to get rid of those decimals. Okay, so you need to change that.
Wait, what does that say?
What?
Harming.
Having.
Oh,
Having no decimals. So we want to get rid of the decimals in the divisor. Move the decimal in the dividend
what's a dividend?
that's the number in house or the cowboy. The same amount of spaces you moved it in the divisor.
Could we,
In other words, what you do on the left, you do on the right. And it'll make more sense when I do examples.
oh, I remember now.
I remember this part.
Oh, math is both sides. Miss Quirrell told me that.
Huh?
Miss Quirrell says math is BS both sides.
Love it. Yes.
Oh,
And then the third step, place decimal on line. And I'll explain all that to you in a minute.
that's how I remember that.
Hey, that's excellent.
Every time we're doing that, she says, remember, math is BS.
Mm-hmm.
I don't think she means it like that, but it's just funny.
That's a good way of remembering it. And I think she kind of does mean that.
She
It's a
never
play
laughs.
on words.
She never laughs when she does it. I totally laugh. Miss Rogers, were you at Miss Coral's party?
No.
Her birthday party?
No.
Why? That's so sad.
I tell you got all this? Sit up, please. If you're tired, you can go to the nurse's office. Okay, sit up, please. Thank you.
At the nurse's office when you're tired?
That means you need to go home.
Oh.
Because I don't allow sleeping in my class. Okay.
I don't think I don't think that's a good thing.
I know. I was like, oh yeah. The homework will be tough.
All right. .1 7.3254.
I thought when you said 3.1 we were doing a new chapter, and we just did that chapter.
Okay. Step 1 says basically you can't have decimals in the divisor. So right here's our divisor. We can't have decimals in the divisor. So we have to move it to get it out of there so it's a whole number. So I'm going to move it to the very end. How many places did I move it? One time, right? What I do to the left, I have to do to the right. If I moved it one place to get it out of there, I have to move this one place to get it out.
Why did we move it?
Because you don't want decimals in the divisor. So you want to move them to where you have a whole number.
You have to.
Yep. Well, do you really want to have? Ugh. No, we want to get rid of them. So I moved it over there one time, so I moved over here. So decimal goes there, and I'm putting it right on top.
So basically, when we move it, we have to move it to the very end.
In this section, yes. And then we have to move this, and so now the decimal, instead of being between 7 and 3, is now between 3 and 2. So now I'm going to rewrite my problem as 31 because I moved it. And now it's 7, 3, and the decimal's here, 0.254. And I'm putting my decimal on top. Before you do any math, you better put that decimal right up there because trust me, it'll help. Now we can start dividing. Does 31 go into 7? But can 31 go into 73? How many times? Twice. So 2 times 31 is 62. I subtract and I get 11. I move down the 2. 31 goes into 112. How many times? First one has it. Kelly?
5 times.
Nope. Joseph?
3 times.
Very good. So 3 times 31 is
93.
93. And I'm going to borrow. 12 minus 3 is?
Minus 3 is 9.
9.
10 minus 9 is 1, so 19.
I borrow. So 19. I'm going to bring down my 5. 31 goes into 195. Let Tanner do this.
Uh, 6 times.
Very good. And 6 times 31 is?
I did 31 times 5.
Here, I got you. 186.
Thank you.
Uh-huh. So we borrow. And 15 minus 6 is 9. I have to keep going because we got to use all of these digits. 31 into 94.
Twice. Or 3 times.
3 times. I get 93. I get 1. And we're going to stop there because we've used all of our digits. Now, depending on the directions, it'll sometimes tell you, it won't tell you what to round it to. Sometimes it'll say round it to the tenths place, the hundredths place. Let's say it says to round to the hundredths place. Okay, let's say it rounds to the hundredths place. Tanner, what digit is in the hundredths place?
6.
6, good job. So we're going to look to the right. That 3 is less than 5, so what happens to the 6?
It turns into 5.
Does it stay the same or is it
Oh,
turn
stays
to a
the
7? Okay, stays the same. So
Right.
then my answer is 2.36.
It's been a while since I.
Oh, that's fine. You're good. Any questions? Yes.
Do we always have to round?
Only if it tells you to. I would say if we need to round, I would round maybe to the nearest whole number,
Whole number would be.
like the 2. Okay? Good question. All right, everyone have this? All right, open your books to page 235 to do examples.
Always a good job. Even though I don't have my book, could I still do some examples?
Uh-huh. Okay. So let's do number 2. All right, Kelly. 1/4 divided by 5/8. Tell me what to do. Huh?
It's already informed. Okay, so you keep the 1/4. Then you change the division sign to a multiplication sign. Then you flip 5/8 to 8/5.
Very good. Can I do any cancellation?
Yes, you can.
What?
For, 4 and 8. 4 times 4 is 1, and 4 divided by 4 is 1. Yeah, it's definitely the correct answer. And then 4 times 8 is 2.
You mean 8 divided by 4
Yeah,
is 2.
I don't like pronouncing stuff.
I like how it's like, yeah.
So then 1 times 2 is,
2, and then
1 times 5 is.
5.
Any questions?
You're in a good mood today, Miss Rogers.
Yes,
That
very
is a
much.
good thing.
Can you give us these problems?
All right. Okay, one more. Big O 5 divided by -1/4.
Okay. Do I just?
Yep.
Okay. You keep the 5.
And what do we have to turn it into?
5/1.
Okay.
Times -4/1.
Perfect. And there's really nothing to cancel because we're dealing with 1, so we just multiply across.
So 5. Oh, sorry.
Yeah.
-20
Okay, so 5 times -4 is -20 over,
over 1.
and that really is,
20. -20.
yeah. Any questions? Okay, we're going to stop there. That's part 1. Remember, we're on chapel schedule, so this afternoon you come back, but we need to sit down and do this, finish up the examples so that y'all can have time to do work, okay? All right, so I'm going to pause here.
What do I do?